Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion on being able to answer questions related to motion graphs. You can be given a displacement time graph, you can be given velocity time graph, for instance, this one, and we have time here in seconds and velocity in meters per second, like that. So how do you answer such kind of question? Now, for instance, we need to describe the motion of this object here. And you can see now that this motion here is a displacement time graph, meaning this is an object moving at a uniform speed. If you're having a displacement time graph and you have a straight line, it means that it will give you uniform velocity or constant velocity. But if you have a velocity time graph and you have a straight line, it means constant acceleration. So from here, we are going to say this object is moving at a constant velocity. So this is a constant velocity, and this is also constant velocity. So if velocity is constant or uniform, both of them are uniform. But this one is moving at a lower velocity. This one is moving at a higher velocity. And the way to find whether it's moving at a higher or a lower velocity is by looking at the gradient of the line that we're having here. If the gradient is steeper, it means it's moving at a higher velocity. Now, this one is a displacement, also time graph, displacement in meters and time in seconds. So something that I want you to realize is from this point here, it means that the object is moving at a higher velocity because the line is steeper. If you look at this point, the line now becomes less steeper. Here, the object is decelerating. If that is basically if it's a displacement time graph, and this object here is accelerating. Yeah, if you look at the gradient of velocity here, increases. So velocity is increasing, it means the object will be accelerating. But here the gradient keeps on decreasing, meaning velocity is decreasing and the object is decelerating. Now, when we look at this velocity time graph here, you'll be asked to describe the motion. In this section, we say the object is moving at constant acceleration. Here the object is decelerating. And at this point, the object is moving at zero acceleration or constant velocity. So those are some of the aspects of this graph that can be identified. So if you are told to work out maybe the acceleration in the region AB, you have to check what reading is here. So let's suppose this is 10 meters per second. Then we are going to, if you are to work out the gradient, remember the gradient of a velocity time graph represents acceleration, which is going to be rise over run. So meaning the acceleration of this object is going to be equal to the gradient, and therefore that means it will be 10 over 5, and that is going to be 2 meters per second square. So if we are working out a deceleration, remember here the object is accelerating, so the gradient here is going to be negative, so meaning it's going to be from 10 to 15 to be negative 10, the rise here is 10 over the run, 10 to 15 is actually 5, so this is negative 2 meters per second square, so meaning the object is decelerating. Now suppose you are told to work out total distance covered or distance covered by the object. We are going to work out the area of this part, we work out the area of this part, then we work out the area of this section, we add all of them together, and that is going to be area under the graph. Under the graph represent the total distance covered, so which means that this is going to be the area of A is going to be half base times height, going to be half times 5 times 10 plus this shape that we are having at this point here is actually a rectangle, so it will be 5 from here to here is 5. This is 10 minus 5, 10 times the height, so it's 5 times 10 plus area of this section here is a triangle, so this from here to here is also 5, so it will be a half times 5 into this, and the height will be 10. So this is going to be 25 plus 50 plus this and this cancels 2 times. This is going to be 5 times, and then it will be 25. So the answer is 100 meters. So in the event they ask you to find average speed, you need to remember that average speed is total distance divided by the total time taken. So average speed is going to be 100 meters total distance divided by the total time, which is 15 seconds. And then you get your answer in meters per second. You have to simplify this. In A, from the origin to A, is object is moving at a constant acceleration. This distance here, A to B, the object is moving with increasing acceleration. Here the object is moving at constant speed, and the object is decelerating, and this object now moves now at another constant speed. So this is an object that is maybe for a parachute. This is motion of a parachute, and it works in the principle that if we are talking of a parachutist who's jumping out of the plane, Yeah, so there'll be upward forces acting. Remember, so immediately the parachutists jump out of the plane. First, we will move at a constant speed, and then air the resistance start building up. That is going to decrease the resultant force, which is acting upward. Then the person will attain terminal velocity when the weight and the upthrust force or the upward force are equal. When the parachute is open, the parachute here, the resultant force will be acting upward. So the person is going to decelerate until he attains another terminal velocity when the downward forces and upward forces are equal. Basically, that is the summary of motion graphs. So if you're new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload the next tutorial, you'll be notified. See you in the next video.